Hey everyone, welcome back to PGCPS TV. This week in 5th grade, we're going to be learning about 2D shapes and geometry. We're going to kick it off with a video about geometry, and then we're going to talk about some vocab.
Have you ever seen a building like this? Believe it or not, it was actually built by a prize-winning architect, Frank Gehry. It is popular for its logic-defying angles and walls that challenge the laws of physics. But here's the irony. 3 years after this complex was opened, he had a lawsuit filed against him for providing defective designs. The building had started to develop cracks, the drainage didn't work, there were leaks and many other issues, and all because of the faulty design of the building. There are many such buildings which have collapsed purely due to defective architecture. But it's not just about the big monuments. Faulty designs can ruin our daily lives too. Imagine having a staircase like this, or a balcony like this. There are just so many things that can go wrong with inaccurate geometry. This is essentially why architects are so concerned about the accuracy of geometrical shapes. And when everything falls in their right place, beautiful architecture is born. Like the Burj Al Arab in Dubai, the Eiffel Tower in Paris, and the Taj Mahal. All of these wonders are nothing but the wonders of architecture, and geometry is at the heart of each one of them. So you see, it's not just about drawing lines and angles, but about drawing the perfect lines and angles for the perfect world.
So like I said, this week we're going to be learning about 2D figures. So we're going to focus on 3 different vocabulary sections today. One on angles and lines, another on geometric concepts, and the last on shapes. So angles and lines. We have acute, right, and obtuse angles that are formed by intersecting lines or line segments, or by line segments or rays that share an endpoint. So an acute angle is an angle that measures less than 90 degrees. And so hopefully some of this terminology you've heard before in 4th grade or even this grade in 5th grade. A right angle, such as this, is an angle formed by perpendicular lines, meaning they meet at a point. So perpendicular lines and the line segments or rays have a measure of 90 degrees. So anything with a right angle has a measure of 90 degrees. So that means that if you have two 90-degree angles, so a flat line like this, the measure of this, the two angles together, is 180 degrees. Another term that we're going to talk about is the term equal or congruent. So two angles, line segments, or shapes that are equal or congruent, that means that they fit exactly on top of. So that means that the angles are the same size. That means that the lines are the same length. So as you can see in this image, these two lines indicate that these are congruent. So they're an exact match for each other. Other angles are obtuse angles, and those are larger than 90 degrees. So we have 3 main angles, which are acute, smaller than 90, right angles, which are equal to 90, and then obtuse angles, which are greater than 90, but less than 180. So again, like I was saying earlier, if this extended out to the whole line, this whole angle would be 180 degrees. So an obtuse angle is in between a right angle and a 180 degree angle. So parallel lines. Parallel lines are lines in a plane that never intersect. So if you think about a train track, if you see these two lines right here, they do not intersect. They fall parallel to one another. Perpendicular lines, like I said in the previous slide, meet at a point. So they do intersect. So again, right here, perpendicular lines, they intersect at a 90-degree angle. Now we're going to talk about geometric figures. So all the figures that we just talked about were considered 2D figures. So 3D figures means they have volume, right? So 2D figures are flat. So a piece of paper would be considered a 2D figure. So shapes that lie in a plane. So if you see any sort of shape like a circle, a square, these are 2D figures. A 3D figure indicates that there is some sort of volume. So instead of a circle, you might have a ball. Instead of a square, instead of a piece of paper, you might have an actual box. So that involves height, length, and width, just like we learned about when we talked about volume. So we have a right triangle and a right trapezoid. These are considered polygons. Polygons are any 3 or more sided shapes. So when you think about a triangle, a square, any of those would be considered 3 or more sides, right? So a right triangle is a type of polygon. It's called a right polygon. So you have right triangles and right trapezoids. That indicates that these polygons have a right angle, So you can see here is the right angle for this one. And then there's actually 2 in this one. So there's 2 right angles in the right trapezoid. So then we have an isosceles polygon. A triangle or trapezoid is called isosceles if it has one set of opposite sides that are equal. Again, equal meaning congruent. So if you can see, these 2 sides of the triangle are equal. And a lot of times we just show that by drawing 2 small lines that indicates that they are congruent. Same with this trapezoid. These 2 sides are congruent to each other. They are the same length. They have the same angle. So these 2 angles are the same. These 2 angles are the same. So that those indicate that they are isosceles. Again, one set of opposite sides are equal. Then you have convex and concave. These are terms we use when we talk about polygons and describe them. So a polygon is convex when there are no dents. So if you can see here, most of the shapes that we've talked about thus far or talk about typically are convex. There's no dent inside. But if you see a concave shape, that means there is a dent. So you think about a cave you can see inside of it. This almost looks like a cave entrance. So this would indicate concave. Convex has no sort of indent. Polygons. So a polygon, like we mentioned earlier, is a closed plane figure made by 3 or more segments. So again, it has to have 3 or more sides. So all of these are considered polygons. They have 3 or more sides. A regular polygon has sides and angles that are all congruent, meaning they're all equal. So that's a regular polygon. So that would be, let's say we had a triangle and all 3 angles were the same. This would be called a regular polygon. This would also be called an equilateral triangle. Symmetrical. So symmetrical means that there's a line of reflection or symmetry between a shape or inside of a shape. It divides the shape into 2 pieces that mirror each other. So again, each of these shapes have lines of reflection. So if you can see the X, if we do this line of reflection, each side mirrors each other. The square, the same thing. There's several lines of symmetry in the square. This bobbish looking thing. But then this shape right here, if I draw a line, it doesn't actually work. They're not symmetrical. If I draw a line of symmetry the other way, it still isn't symmetrical. So this last one doesn't have a line of symmetry. 2 other triangles, kind of similar to terms we've used earlier, but remember if you heard the term acute meant less than 90 degrees. So an acute triangle is a triangle where all the angles are less than 90 degrees. A right triangle is just like that, where it has one angle at least that has 90 degrees. So an acute one means that all of these are less than 90, each of them. But in a right triangle, at least one of the angles has 90 degrees. 2 other triangles, we've kind of touched on it earlier, but an equilateral triangle means that all sides are equal, which also means all angles are equal. So this is what we were talking about when we said a regular polygon. So again, we indicate with the small lines. We can do 1 line to indicate that they are equal. We can also do 2 lines to indicate they're equal. So those little lines typically, or dashes, indicate that they're equal. So equilateral triangle means that all sides, all angles are equal. An obtuse triangle. So remember we talked about acute triangles, meaning all the sides, all the angles were less than 90 degrees. An obtuse triangle means that the triangle has one angle that's greater than 90. So in a right triangle, one angle has 90, but in obtuse, one angle has more than 90. So if you can see here, this angle right here is 110 degrees. So now we're going to talk about quadrilaterals, which are a pretty big group when we talk about geometric shape. So a quadrilateral is just any polygon with 4 sides and 4 angles. So if you remember our term polygon just meant 3 or more sides, 3 plus sides. So it's a big group of polygons, right? A lot of shapes are considered polygons because a lot of them have 3 or more sides. But then a group of the polygons have 4 or more sides. So that would be quadrilaterals and other shapes. So quadrilaterals specifically have 4 sides and 4 angles. So even though this doesn't look like a shape you've seen before, it has 4 sides and 4 angles. 1, 2, 3, 4. So that means that it is a quadrilateral. Then you have an even smaller subcategory, which is parallelograms. A parallelogram is a quadrilateral with 2 pairs of parallel sides. So that means that because it's a quadrilateral, it has to have 4 sides and 4 angles, but it also has to have 2 pairs of parallel sides, 2 pairs. So if you can see here in red, these 2 sides are parallel. If you can see here in green, these 2 sides are parallel. So it meets the qualification that it has two pairs of parallel sides, and it's also a quadrilateral because it has four angles and four sides. So that means it's a parallelogram. Quadrilaterals don't have to have parallel sides. A rectangle. So a rectangle is a parallelogram with four right angles. So again, remember, because a rectangle has four sides, four angles, so this means it's a quadrilateral, but it also has two pairs of parallel sides, so it also means it's a parallelogram, but it's even more specific because it has four right angles. Regular parallelograms don't have to have right angles. So an even more specific parallelogram is a rectangle because it has four right angles. Then we have something called a kite. A kite, or sometimes it's called a deltoid, has one pair of opposite angles that are congruent. Again, opposite angles that are equal to each other. So if we see here, these two angles are equal to each other. They also have two pairs of adjacent sides that are equal. So two pairs of adjacent sides. Adjacent meaning right next to. So if you have perpendicular lines, these lines are adjacent to each other. They connect, they intersect. So these two sides are adjacent and they're equal to each other. They're the same length. And then you have these two sides that are also the same length and equal to each other. But that doesn't mean that they're equal to the other pair of sides on this side. So it has to have two pairs of adjacent sides that are equal. Other quadrilaterals, we have something called a trapezoid. A trapezoid is a quadrilateral with at least one pair of parallel sides. So if you remember, quadrilateral just means four sides, four angles. So a trapezoid is a specific quadrilateral that has at least one pair of parallel sides, at least one pair. So these are parallel, these are parallel. Then we have something called a rhombus. A rhombus is a parallelogram with four equal sides. So again, some of these meet several categories, right? As we saw in the rectangle was considered a parallelogram and a quadrilateral. So maybe not today, but maybe in the next class, we'll talk about how that looks in terms of putting things into different categories and how many categories different shapes fit into. So a rhombus, again, is a parallelogram with four equal sides. So if we remember what a parallelogram means, this is really a quadrilateral that has two pairs of parallel sides. Again, quadrilateral meaning it has four angles and four sides. So rhombus has four angles, four sides, two pairs of parallel sides, but also four equal sides. So not only does it have four sides, but the four sides have to be equal. That doesn't mean that they have to look like a square, but if you can see here, this looks like a slightly turned square. So, but if we can see all the sides we see with the small lines mean that they are the same length. Not only do they have the same length, but they have four angles. So that meets the qualification here. Two pairs of parallel sides. These two are parallel. These two are parallel. So that meets that qualification. So the rhombus is considered both a parallelogram and a quadrilateral. Then we have a square. Most of us know what a square is, but a square actually fits into many categories. So a square is a rectangle with four equal sides. If you recall, we talked about a rectangle, and a rectangle is really just a quadrilateral and a parallelogram, and it has four right angles. But a rectangle doesn't have to have equal sides, right? You can have a 3-inch tall rectangle that has 7 inches across. So as long as it has the four right angles, it meets the qualification. So a square is just really a rectangle, but instead it has four equal sides. So that's really the main difference there. So a square is not only a rectangle, but it's also a parallelogram, and it's a rhombus technically, and it's a quadrilateral because it has at least one pair of parallel sides, and it's part of the quadrilateral family just generally. So then the last one for this slide is called a chevron. A chevron is a quadrilateral in a V shape, and it's concave. Remember we talked about convex and concave? A shape that doesn't have indents would be considered convex. A shape that has an indent like this would be concave. So a chevron is a quadrilateral that's in a V shape and it's concave. So now we're going to work on the 510 apprentice task. So it's called trapezoids and parallelograms. So just before we start, let's define both. Again, in our vocab, we said trapezoids were quadrilaterals that had at least one pair of parallel sides. And we said that parallelograms were quadrilaterals as well, but they had two pairs of parallel sides. Now let's get into our questions. So the first part is just shapes on a grid. So we have Jose and Ruth, and they're each drawing shapes by connecting 4 points in the order that they're plotted. So they both plot a point at 7, 9. So again, 7 is our x-axis, which is left and right, and 9 is our y-axis. So we're going to go across to 7 and then up to 9. So we're going to plot this for both of them. They both also plot the point 1, 9. So again, across 1 and then up 9. So we go across 1 and then up 9. Jose plots his third point 6 units down and 3 units to the right of the previous point. So again, we go 6 from this point 1, 9. We're going to go 6 units down and 3 units to the right. He then plots his last point at 10, 3. So again, we're going to go across 10 and then up 3. And these are our 4 points, and they would be connected. Ruth then plots her third point 6 units down and 2 units to the right of the previous point. So again, from the point 1, 9, we go 6 units down and then 2 units to the right. So then she plots her last point at 5, 3. So that's, again, 5 across and then 3 up. So 5 across and then 3 up. So this is what Ruth's shape looks like. So even though they had very similar initial points, or the same initial points, their second 2 points made their images different. So let's look at our next question. It says, name the 2 shapes that Jose and Ruth created. So again, both of these shapes have 4 sides. So we know that they're both quadrilaterals. We can see that Jose's shape has 1 pair of parallel sides and then another pair of parallel sides. So this is 2 pairs of parallel sides. So by definition, this is a parallelogram. Now we look at Ruth's. So we see that Ruth's has 1 pair of parallel sides. The other 2 sides are not parallel, but they are a reflection of each other, but that does not mean that they're parallel. So we have 1 pair of parallel sides, and like we mentioned earlier, a trapezoid has at least 1 pair of parallel sides and is a quadrilateral. So this would be considered a trapezoid. The next part says decide whether each statement is true or false. Explain why and draw a sketch that illustrates your thinking. So the first sentence says all parallelograms are quadrilaterals. So again, definition-wise, a parallelogram is a shape that has 2 pairs of parallel sides. So this could be a rectangle, this could be a square, this could be a rhombus. A rhombus is just a parallelogram that has equal sides. So again, 2 pairs of parallel sides. Or it could just be a parallelogram, which isn't a rectangle, a square, or a rhombus. So it could just be a regular parallelogram. We can see here that all of these meet the qualification that they have 4 sides. And that is exactly what a quadrilateral is. It's a shape with 4 sides and 4 angles. So yes, this is in fact correct. All parallelograms are quadrilaterals. So this is true. The next sentence says all quadrilaterals are trapezoids. So again, we're thinking, if we're saying all quadrilaterals, that's a very big category. So quadrilaterals just mean 4 sides, 4 angles. So then we think about a trapezoid. A trapezoid specifically is a shape that has 1 pair of parallel sides. This could be a square. It has at least 1 pair of parallel sides. This could be a traditional trapezoid where it's at least 1 pair. This could be a parallelogram because it has, again, at least 1 pair. So all of these are considered trapezoids. But all quadrilaterals don't have to be trapezoids. Let's think about a quadrilateral that isn't a trapezoid. So if we think about any 4-sided shape, So that could be something like a shape like this. It has 4 angles and 4 sides, but it doesn't meet the qualification that there is one pair of parallel sides. Another example could be a kite. If a kite looks like this, none of the sides are parallel. They might be a mirror of each other or a reflection, but they're not parallel. So this does not have at least one pair of parallel sides. So this would be a quadrilateral because it has 4 angles and 4 sides, but it isn't a trapezoid. So not all quadrilaterals are trapezoid. This is false. The next one says some trapezoids are parallelograms. So we think about some trapezoids. So again, a trapezoid just means at least one pair of parallel sides. So again, this can be something where it only has one pair of parallel sides, so right here and right here, or it could be something that has 2 pairs of parallel sides. It just means at least one pair of parallel sides. And we know that parallelograms have to have 2 pairs of parallel sides. So we can see that some trapezoids, just like this, are parallelograms. Not all of them though, right? Because some trapezoids just have one pair of parallel sides, but some of them have 2, and that's okay because it just needs the qualification of at least one pair. So this is true. The next one says some parallelograms are trapezoids. So just like we were doing earlier, a parallelogram is something that has to have 2 pairs of parallel sides. So as we showed, a parallelogram could be a rectangle. But a rectangle also at least has one pair of parallel sides. So this rectangle is considered a parallelogram and a trapezoid because it has at least one pair of parallel sides. Parallelograms are in fact also trapezoids. So this is true. The next one says every trapezoid has 2 right angles. So let's think about different trapezoids that we know. We know that this one looks similar to the one Ruth had. Again, trapezoid just means at least one pair of parallel sides. I know that a rectangle is also a trapezoid and a parallelogram. It has at least one pair of parallel sides, but it has 2 pairs. So if we say every trapezoid has 2 right angles, well, in the case of a rectangle, that's true. It has at least 2 right angles. But in the case of other trapezoids, it might not have any right angles. So to say that every trapezoid has 2 right angles would be false. Then the last one says a trapezoid can have 2 right angles. So if we see our image here, yes, it can have 2 right angles. This one has more than 2 right angles, but we can also show a trapezoid with just 2 right angles. So again, this shape right here has 2 right angles. It has at least one pair of parallel lines, and it is technically a trapezoid. So a trapezoid can have 2 right angles specifically. So this is true. So thanks for tuning in today, guys. I hope you guys learned a little bit. On the next slide, you'll find a few different questions and my email if you need to reach out to me. I hope you guys have a great day and check us out next week.